Okay, hi, good morning. So today let us see a problem on moment concept. So the problem is determine the resultant of the force system acting on the plate shown in the figure about the A. So the question is, so we have to calculate or we have to locate the position of the resultant force with respect to point A. Here there is a lamina is given. So four forces are acting on this lamina. So you can see A, B, C, D. So at the point a force of 14.14 Newton with a slope of 1:1 acting. At the point B, vertical force of 20 Newton acting in the downward direction. At the point C, 5 Newton force which is acting with an inclination of 30 degree to the horizontal, and 10 Newton force which is acting at the point B with an inclination of 60 degree to the horizontal. In addition to the four forces, there is an applied moment of 10 Newton meter, whose location is not specified, which is specified on the line CD. So now this forms a non-concurrent force system. So you know already how to resolve the forces and how to calculate resultant force for the concurrent force system. So whereas this is a non-concurrent force system, the resultant force, the location of the resultant force the location of resultant force depends upon the moment about which we calculate. For example, so the location of the resultant force with respect to A is different with the location of the resultant force with respect to point B. So if we calculate the moment about A, so we can locate resultant force with respect to point A. So if we calculate moment about B, we can locate the resultant force with respect to point B, like that. So that depends upon the point about which we calculate the moments. So now in this problem, it is asked to calculate moment. It is asked to locate resultant force with respect to point A. So therefore, we have to calculate moment about the point A to calculate resultant force with respect to point A. So first step, so we have to calculate the resultant force. Then we have to calculate the inclination of resultant force theta. Then its distance from the point A. Then x and y intercept of the resultant force. So first, to calculate the resultant force, again we have to split the forces into their components along x and y directions. So once we split the forces, we can calculate summation of forces along x direction and along y direction. Once we calculate the forces, so we can calculate the resultant force. So first, split the force into their components. See here, so 10 Newton force is given, which is acting at a 60 degree to the x axis. So now split that force into two components. Now I am showing the resolution of forces are splitting into their components in the figure itself. So we can split this force into two components. So one is along x direction and another one is along y direction. So here the x component of this force can be written as 10. So cos 60, and here it is 10 sin 60. So x component is 10 cos 60. So and y component is 10 cos 60. Here it is 10 sin 60. So now the inclination of the 14.14 Newton is not given directly, but it is specified in terms of slope, one vertical to one horizontal. That means, so it is just like a triangle. So if you consider this as theta, then this will becomes opposite, adjacent, and this will becomes hypotenuse. So we know opposite, we know adjacent. So the trigonometric function relates opposite and adjacent is tan theta. Therefore, so we can define tan inverse. So tan inverse of 1 by 1 is nothing but 45 degree. Okay, so therefore, so the inclination of this force is 45 degree. Now split that force into x and y direction. So if we split this force, so this force can be split into, one is along vertical direction, another one is along horizontal direction. So I am splitting this force at this point. So here it is, so 14.14 cos 45, and one more is, so here it is, so 14.14 sin 45 degree. So next, the third force. C, which is acting at the C with an inclination of 30 degrees. Again, we can split into two components. So C I write down here. So split into one as vertical force and one as horizontal force. So vertical force is 5 sin 30 and 5 cos 30. So those are the three forces we have to split. So it is shown. Now let us calculate the sigma fx. So sigma fx. Take summation of all the forces which act along the x direction by considering the sign convention. Forces acting from left as positive, opposite as negative, similarly upward as positive and downward as negative. So it is a sign convention I am using. So now take the forces which act along the x direction. The first force is 10 cos 60. So 10 cos 60 is the one force. So which is acting from right to left according to my convention, it is positive, hence plus 10 cos 60. Next force is 5 cos 30. So plus 5 cos 30 plus y, because according to my sign convention force is acting from left to right, therefore it is positive. Next the third force is 14.14 cos 45. So plus 14.14 cos 45, the third force. And any other forces? No, there is no other forces which acts along x direction. So three forces are there. So we have considered all the three forces. So therefore the sigma fx value works out to be
19.33
Newton. So this is the sigma fx value. Now come to sigma fy. That is summation of forces acting along the vertical direction. Now take the first force which is acting at the point A. According to my sign convention, which is acting in the upward direction, hence it is plus. Therefore plus. So plus 14.14 sin 45 is the first force. Next at the point B there is a vertically acting downward force is there. According to my sign convention, it is minus. Therefore so minus 20. Next at the point C, so there is a vertical upward force is there. According to my sign convention, it is plus. So plus 5 sin 30, and next the last force at the point D is 10 sin 60, which is acting vertically downward. So according to that sign convention, it is minus. Therefore so minus sin 10 sin 60 minus 10 sin 60. The value works out to be
16.16 Newton.
16.16
Newton.
Positive or negative?
Negative. Minus.
Okay. So here sigma fx is positive, sigma fy is negative. Now calculate the resultant force. So R is equal to the root of sigma fx square plus sigma fy square. So therefore the value of R is
25.2 Newton.
So 25.2 Newton. So this is the value of the resultant force. Now we have calculated the resultant force. Next we have to calculate the theta. That is the inclination of the resultant force. Theta is equal to tan inverse of sigma. So fx by sigma fy by sigma fx. Sigma fx. So here we have to take the modulus to take theta as positive. Therefore, so theta is equal to sigma fy. Sigma fy you can see. So 16 point tan inverse of modulus of 16.16. So divided by 19.33. So therefore the value of theta works out to be
39.9 degrees.
So 39.9 degrees. So this is the inclination of the resultant force. So we have calculated so resultant force and its inclination. Next, what is the distance of the resultant force from the point A is the question. To calculate the distance of the resultant force from the point A, so we have to calculate summation of all the moments about the point A. So you know, so already, so moment is nothing but force into perpendicular distance. So according to this condition, we have to calculate the summation of moments about the point A. So let us start. So about A, here at the point A, there are two forces 14.14 cos 45 and 14.14 sin 45. So we cannot consider both the forces because of course force is there but distance is not there. Force is there but distance is not there. So therefore we should not consider these two forces. Now come to point B. So we will go in the anti-clockwise direction A, B, C, D like that. So from the point B, so if you consider moment of the 20 Newton force about the point A, so which is force into distance. So force is 20 Newton, so which creates say clockwise moment. So we can again consider sign conventions for the moments. Like if the moment creates clockwise moment, the moment can be considered as positive. If it creates anti-clockwise rotation, then it can be considered as negative moment. So here this force, so 20 into distance about the A is 4 meter, so which creates clockwise. According to my sign convention, it is positive. Therefore, the moment can be written as so 20 into 4. So 20 into 4, which creates clockwise, hence it is positive. Next, the next force, two forces here at the point C. So 5 sin 30 and 5 cos 30. So we have to consider moment of both the forces. So both the forces form the moment about the point A. So if you project 5 sin 30 on the point A, so we will have a perpendicular distance of 4 meter. And at the same time, if you consider this force, so this force will create anti-clockwise moment about the point A. You can just imagine the rotational effect of that force about the point A. It is so in the anti-clockwise direction. Therefore, 5 sin 30. So 5 sin 30 is the force. Its distance about the A is 4 meter. 4 and the direction as I told, so which creates in the anti-clockwise rotation. Hence I consider this as minus. Next, the one more force is 5 cos 30. So 5 cos 30 again you can imagine, so which creates clockwise rotation. Therefore it is plus. So plus 5 cos 30 is the force and distance about the point A, you can see here it is 3 meter. About the point A is 3 meter. So next, the remaining forces are at the point D. So one is horizontal and one is vertical. So again, I cannot consider 10 sin 60 because if you project this force, it will come and meet at the point A. Of course, force is there, but perpendicular distance to form the moment is not there. Therefore, we cannot consider this force, so distance is not there. So we can consider 10 cos 60 force. So 10 cos 60, so 10 cos 60 is the force and its distance about the point A is 4 meter, 3 meter. You can see here, it is given on one side, it is 3 meter. So 3 again, so the direction you can imagine it creates a clockwise rotation. According to my sign convention, it is positive. Hence, positive. And there is an externally applied moment of 10 Newton meter is there that we have to consider in the calculation. So plus 10. So the net moment works out to be. So the summation of moments about A works out to be
95.18.
95.18 Newton meter. So unit is Newton meter because all the forces are in terms of Newton and distance is in terms of meter. Next, calculate the D, that is the distance of the resultant force from the point A. So that can be calculated by using Weygmann's principle of moments. That is D is equal to summation of moments about A, so divided by the resultant force. That is equal to the summation of moments about A is so 95.18 divided by, so the resultant force is, we have already calculated, so 25.2. So that is equal to D is equal to
3.77 meter.
So 3.77 meter. That means the resultant force lies at a distance of 3.77 meter from the point A. Next, we have to calculate X and Y intercept of the resultant force. So, okay, now we have to calculate the X and Y intercept of the resultant force. So, just note down the values here somewhere. So, here we know sigma Fx is equal to it is 19.3 So 19.33. So sigma Fy is equal to 16.16 minus 16.16. So minus 16.16. So resultant force, so 25.2. So theta is equal to, so 39.9 degrees. So moment about A is this 95.18 and distance B is equal to 3.77 meters. So let us see the calculation of x and y intercept of the resultant force. So now the x intercept of the resultant force, x intercept of the resultant can be calculated, so by using, so x intercept is equal to summation of moments about A divided by, so summation of sigma f y. So that is equal to summation of moments about A, we have already calculated, it is, so 95.18. So 95.18, so divided by sigma fy 16.16. So which is minus 16.16, that is equal to, the value of x works out to be
5.88 minus 5.88.
Minus 5.88 meters. Next, y intercept. So y intercept is equal to sigma m at A divided by sigma f x, that is equal to, so 95.18, so divided by sigma fx we have already calculated, so which is 19.33. So 19.33, the value of x intercept works out to be
4.92.
so 4.92 meter. So that completes the problem. So we have calculated the resultant force, we have calculated the theta value, that is the inclination of the resultant force. So we have calculated distance of the resultant force from the point A and x and y intercept of the resultant. Now the next question is, we have to represent this resultant force in the final diagram. So I'll write down the final diagram here. Just write down the diagram as it is. So this is the point A. Now we have to locate the resultant force with respect to point A. As I told, so in case of non-concurrent force system, resultant force lies based on the moment about the points we consider. Therefore, so now which is at a distance of 3.77 meter from the point A. Then how to locate it? So can I locate the resultant force in the upward direction or in the downward direction or above the point A, below the point A? So that's all depends upon your sigma fx and sigma fy values. So here sigma fx is positive of 19.33 and sigma fy is minus 16.16. That means the one value should be positive and another value should be negative. In such a way, you have to locate the resultant force. Suppose, so if you place the resultant force, say like this, assume that you are placing the resultant force here. So if you are going to write down the resultant force here. What will happen if you resolve the force into two components? So along x and y direction, so x will be positive, y is also will be positive. So therefore this case is not possible. If you reverse the force, so what will happen? So if you resolve this force, one will be along y, x is negative, y is also will be negative. Like this. So if I place the force like this, so assume that the force is in the upward direction. So if I split this force, so y will be positive, x will be negative. So therefore this is also not possible. Now assume that this force is acting in the downward direction. Okay, now split the force. So one force x is positive and y will be negative. So you can see, so sigma fx is positive and sigma fy is negative. So therefore, so we have to place the resultant force in the downward direction at a distance of, so 3.77 meter. 3.77 meter, which is nothing but d, and this is the resultant force. And x and y intercept as we have already calculated. So this is the x intercept, so which is 5.8 meter. So 5.88 meter, and the y intercept. So So y-intercept we calculated 4.92 meter, and the value of the resultant force R is equal to 25.2 Newton, and its inclination. So with respect to horizontal direction, always we have to write the inclination with respect to horizontal, because we have used sigma Fy by sigma Fy in calculation of the theta. So there the theta value is 39.9 degrees. So this is the final diagram. So let's complete the problem.